Hey guys, this video we are going to learn about monotonic sequences. So suppose we have a sequence like this, right? So A sub n, so this one is a sequence, right? And it is called strictly increasing if so A sub n, this is a general term, A sub n is smaller than B sub n, next term, A sub n plus 1. So this one should be true for all n, right? So let's try to understand increasing or non-decreasing. So this one is called increasing. This sequence is an increasing sequence. Then here you have greater than or equal sign, right? So let's try to understand this using some examples, right? Let's consider this sequence n or n plus 1, this one. So what is the first term? First term would be 1 over 2. Second term, you have to subbing 2 into here, then you get this second term, which is 2 over 3, and third term 3 over 4, fourth term 4 over 5, like that, right? And this is the general term n over n plus 1, and this goes on like this, right? So let's write the decimal number for this. This is something 1/2, that means 0.5, and 2/3. Alright, these are the decimal numbers for these rational numbers. So this one is 0.5, and 2/3 is approximately equal to 0.667, which is bigger than 0.5, and the 3/4 is 0.75, which is bigger than this number here, and this one is greater than 0.8, is greater than 0.75, right? So this sequence seems to be increasing, but we don't know. We checked only first 4 terms of this sequence, so we have to so we know that the limit of this one. So how do you find the limit? So you divide both denominator and numerator by n. When you divide denominator and numerator by n, you get something like 1 over 1 plus 1 over n. As n tends to infinity, this term becomes very small, getting very small as n takes large values. So when you compare this term with this, can neglect this term, or basically you can, if you understand this, the limit as n tends to infinity, the limit of 1 over n is 0, right? Then 1 over the limit of n, this whole number approaches 1, right? So this sequence approaches 1. So this is the first term of that sequence, which is equal to 0.5. This is the second term, which is approximately equal to 0.667, right, like that. So we checked first four terms. So this series looks increasing, but we cannot say it is increasing. You have to prove that one. How do you prove? So consider, so this is the general term. A n is n over n plus 1, right? So let's take the consecutive number to this. The consecutive term is a sub n plus 1, which is n plus 1. So you replace n with n plus 1, then you can find the next term of the sequence. So the numerator will be n plus 1 when you replace n with n plus 1. So when you replace n with n plus 1, the denominator becomes n plus 2. Now we want to check whether this one is increasing. So these things, this one is true for all integers. Alright, so let's take the difference between these two terms. N plus 1 minus a n. The difference, when you simplify this one, what do you get? So when you consider the difference between a sub n plus 1 and a n, so you get this one here. So 1 over n plus 2 times n plus 1. So you know that n belongs to integer set. So n would be 1, 2, 3, 4. This one is true for all natural numbers. Here n takes 1, 2, 3, and so on, right? So because of that, this term is positive all the time. This one is positive, greater than 0 for all n in natural numbers. That means this term is bigger than this one. That means a n plus 1 is bigger than a n for all n. Now this one, so now you can say here, so if you so you showed that for any n, any integer, any positive integer, a sub n plus 1 is bigger than a n. That means this, you showed that this sequence is increasing, strictly increasing. Here strictly increasing, right? You show that this distance, this difference is bigger than 0, not greater than or equal, just greater than 0. So that means you can, so you showed that, so n sub n plus 1 is greater than, strictly greater than in a sub n. This is true for all n. That means you can say this sequence is strictly increasing, right? So that's how we show this a sequence strictly increasing or decreasing. If this is negative, right? Suppose you show that, suppose this distance becomes negative number, this is becomes negative number. Suppose we get a negative number here, then this is less than, this one is less than 0. That means that sequence is not increasing, decreasing, right? So it's right. So these are easy. So I hope you understood these definitions. So what a strictly increasing sequence is, or what a strictly decreasing sequence is. An increasing sequence, this is called monotonically increasing or increasing sequence. So only difference is here you have greater than or equal sign. Here strictly no smaller than, here less than or equal sign, here smaller than, less than only, right? Strictly less than. Here you have smaller than or equal sign, then we call that sequence is decreasing, increasing, right? I hope you understood monotonic sequences, right? My next video I will talk about bounded sequences, right? And I will provide some exercise on monotonical sequences, then you can practice a little bit, then you can understand clearly what a monotonical sequence is, right?